we are still learning about matter because matter really matters. And this is what we will do today. Who can read this slide for me? Who would like to start off our class with some reading? Who wants some practice? I see 2 hands up. Let's start with Riku. Go ahead, Riku.
Today we will discuss your observation about solid, liquid, and gas. Learn how scientists classify matter.
Very good. Okay. So first we'll talk about your homework. Then we're going to learn about classify. Raise your hand in your video if you've seen the word classify before. Does anyone recognize this word? You've seen it before? No, that's okay. One person, Leo. Pony, maybe you've seen classify before. Thomas, you've seen.
No, I heard it before. I heard it before. I think it is a glass stand.
Ah, okay, you thought it was a different one. So we're gonna learn this new word today. Remember to always answer in complete sentences. Let's get started. The first one was to discuss your observations about solids, liquids, and gases. So take your homework out. Let's share your homework and some of the properties you observed. Who would like to start?
Miss Miranda.
Yes, Leo?
I only do 2 properties on gases and liquid.
Okay, if you hear third one, you can write it down now, Leo. Who would like to start?
Me.
Kat, I think I saw your hand go up. Did you want to share your homework, Kat?
Liquid. Pepsi is a liquid. It takes its shape from its container.
Excellent. Nice. Let's hear another one. How about Pony? Go ahead, Pony.
The first thing is my fan. It is hot. I can bring it go with me when I'm going on holiday. My fan helps me cool down. Milk is a liquid. It is white. It smells sweet. It tastes good. I mix it with fruits to eat. It is really yummy. Air is a gas. It is air, the air we breathe everywhere. A wind is moving air. We can't smell or see it. Air is used for breathing. Bye-bye.
Excellent. Very good. I like how you talked about your sense of smell, your sense of taste. Excellent work, Pony. Who else would like to share? Thomas, I see your hand up. Go ahead.
My toy car is yellow, green, and gray. It is hard and smooth, and it is stiff.
Excellent. Great use of all of the different properties, including flexibility. Jack, go ahead.
I choose my pencil case. It's bent. It's red. It's smooth.
Excellent. Very good. You both read about solids. I hope you also did liquid and gas. Can we have one more person read their liquid and gas? Lion, go ahead. Read your liquid and gas.
The liquid in front of me is a hot cup of coffee. The hot cream, nice and mixes air. The air don't have color and no smell.
Very good. The air does not have color or smell. Nice job, Lion. So you guys did some exploring of solids, liquids, and gases. Now we're going to use those properties to talk about classifying matter. Classify. Who would like to guess what this means? I know a few of you have seen it before. Does anyone want to tell the class what they think classify means? I think Leo and Thomas maybe had their hand up earlier. Either of you want to try and guess what classify means? Leo, go ahead.
Classify means we find out something.
We find out something? Kind of. That's a good start. Anyone else have a guess? Riku?
Classify means example that we have a box of something and we put it in the ones that toys and something else.
So what is that called? You're making what? Different? Starts with a G.
I know.
You're making different
Group.
Yes, good help, Jack. Making different groups. Riku's right. You have a box of something. You put your toys here. You put your pencils here. You're making different groups. Classify. We make different groups. Classify. How can we group these objects? How can we classify them into different groups? Let's hear from Potato. Go ahead.
We compare it.
We compare them, yes, but Potato, what property could we use to classify them?
Shape.
Good. Full sentence. We can classify them.
We can classify them by shape.
Excellent. Everyone, please circle the 3 different groups of shape. Please classify these by shape. Go ahead and circle to classify these by shape. All right, I see our circles, our triangles, and our squares. All right, what else can we classify these by? What else? Tom?
We can classify this shape by color.
Excellent. We can classify them by color. Everyone, please circle let's do blue. Circle the blue color. Let's classify these by color. Circle all the blue ones. All right, now circle all of the red ones. Excellent. You have classified these shapes by their color. What other property can we use to classify them? So far we have shape, color. How else could we classify them? Anyone I haven't heard from yet? Casper, go ahead.
Size.
Can you say the whole sentence?
We can classify from size.
Very nice. Everyone, go ahead and circle shapes to classify them by size. Very good. Excellent. So, in this case, classify is a verb. We classify things. Okay? So, here, classified, the past tense of this verb. You just classified those objects. Good job, everybody. Yay, we all know how to classify now. Who can read this question for me? Let's have Ben. Ben, can you read this one on the right?
What did you use to classify those objects?
Good. Can you say classify?
Classifies.
Okay, so what did you use to classify those objects? Very good. So Tiger said we use size, we use shape, and we use color. What are these? What did we use to classify those objects? What are these three things called? Mia?
Properties.
Excellent. We used properties. Mia, can you please read this for me?
Great work. You used properties to classify those objects into different groups.
Thank you. Okay. And actually, let's have everyone read this bubble because this bubble is really important. Go ahead, everyone. 1, 2, 3.
Great work! You used properties to classify into different groups.
Very nice, everyone. So we can classify objects by temperature, mass, color, texture, and other properties. Who can tell me what temperature is? Who can tell me what temperature is? I'm looking for someone new. Nick, John, Robert, Perry, Dragon. Temperature. What is temperature? Dragon, go ahead.
Weather outside.
The weather outside, that's a good start. Could someone help Dragon finish this idea? Robert, what is temperature?
It means how hot or how cold something is.
Excellent, very good, Robert. What is mass? Remember this word from yesterday. What is mass? Susie?
Mass is how something weigh or
How much something weighs or how much what it has. Excellent, very good. So Susie said mass, how much something weighs or how much mass it has. Remember, or how much matter it has. Remember, more matter equals what? Who remembers the rest of this phrase? More matter equals potato?
more mass.
Very good. More matter equals more mass. So we can use all these different properties to classify things. Let's see, can I please have Nick, go ahead and read this for us.
Scientists classify things too. They classify matter using the different properties. How do you think scientists can classify matter into groups?
Okay, good. That reminds me, let's all practice how to say this word together. We need to say our new word. So can everyone unmute and say classify?
Classify.
So we have class. The first part is class. And then we have and then we have phi, not fee, phi, classify. So scientists classify things too using properties. Raise your hand. How do you think scientists can classify matter into groups? Jack?
By observation.
By observation, excellent. They can use their observations. What?
Miss Maria,
Yes, Jack?
we can use taste, like we drink water and we drink coffee, and we classify.
Excellent. Yes, you're right. Whenever we drink things or eat things, we could classify them by taste. Very good. So scientists classify matter using observations. What are the main groups they can classify matter into? How do they classify matter into what main groups? Anyone know? Lily? Ben? Tuệ Anh? Scientists can classify matter into groups. What are the main groups they can put matter into? There are 3.
Size, shape, and color.
Not size, shape, and color. That's a good guess, though. Thomas?
Solid, liquid, gas.
Excellent. Yes. Exactly. They observe properties to classify matter into solids, liquids, and gases. Everyone, please unmute and read this. 1, 2, 3.
Exactly. These are the properties to classify matter into solids and gases.
Very good. Nice work. Who would like to read this for us? Anyone like some practice reading? Lily, go ahead.
How can we classify objects? When we classify, we group things by their properties. We put things that are alike in the same group.
Very nice. Excellent reading, Lily. So, how do we group things? How do we group things? Using what? What do we use to group things? Alex, what do we use to group things?
We group things by the properties.
Very good. We group things by their properties. Mia, how do we group them? Do we put things that are alike in the same group, that are different? What do you think? How do we group them? Do we put them together if they're the same property or if they're different properties? What do you think?
Different.
So you think we put things that are different in the same group? Remember when we classified the shapes by color? Did we put the ones with the same color in the same group or different colors in the same group?
Same.
Good, the same color in the same group. So we want to classify things that are alike, that are the same. Okay, good job, everybody. Classify, okay. So we know scientists classify matter into solids, liquids, and gases, but how? Who can tell me the properties of solids? What makes a solid a solid? Leo, go ahead and give me one.
It is stiff.
Is it always stiff? What about a feather or a piece of paper? That's a solid, but is it stiff?
It is hard.
Is a pillow hard? Everyone think, how is a solid different from a liquid or a gas? Robert?
Solid keeps its shape.
Very good. The solid.
Sometimes it can bend.
Very good, but sometimes it can bend if it is flexible.
Flexibility.
Yes, excellent job, Robert. You can tell me, how do you know this is true, that solids keep their shape? What is your evidence? Who can give me some evidence that solids keep their shape? Potato?
So we can look at the thing.
Yeah, we can look at it. We can observe it. Exactly. We can observe it and see that. Properties of liquids. Who can tell me properties of liquids? Pony. Go ahead, Pony.
Supposed to take the shape of its container.
The shape of their container. Very good. And there's one more. Who can tell me what happens if we move the container? If we move it to a different container, what will happen? Tiger, what happens if we move it to a different container? Excellent. The last one, properties of gases. We haven't really learned about this, so this one's a little harder. Who thinks they know a property of gases? All right, Casper, go ahead and give it a try. What's a property of gas?
The gas does not have shape.
Excellent. It will fill the space it is in. So for example, if I have this big container and this little one, and I fill it with a liquid, the liquid will fill this up all the way, and in the big container, it'll just be down here, right? This is for a liquid. It'll change shape. For a gas, let's say these are little pieces of my matter. This is the gas. 1, 2, 3, 4, 5, 6, 7. I have 7. This is the gas spread out in the big container. And in the little container, it's the same. It fills its container, okay? It takes up different amounts of space, even though that it doesn't change. It has no shape. It'll just float around, fill up the space, move, okay? How do you know that gas has no shape? Who can give me some evidence? Maybe with something in your house, something you've seen. How do you know gas has no shape? Jack?
Observation. I see
Observation. What did you observe, Jack?
when I eat my noodle, it is hot. And I see gas float away. It don't make any shape.
Excellent. Great. When you're eating your noodles, the gas coming off of it doesn't have any shape. It just floats away.
Can I have another evidence?
Go ahead, Potato. Tell us your evidence.
The gas like a cloud. It was begin in the hot water and it floated. It in the to make a cloud and that with gas. It can make it shape and it float.
Excellent. Very good. Okay. Nice example with the clouds, with water vapor making clouds. All right. Let's do some matching. Go ahead and draw a line. This first one is the perfume while it's in the bottle. It's in the bottle still. Perfume in a bottle. Nice work. Good job, everyone. Why do you think that? Who can tell me why? I'll call on someone at random then. Ben. Ben, how do you know that perfume in the bottle is a liquid?
Because it's a water.
Because it's a water, but how do you know that? What do you see that tells you it's a liquid? What is the property that tells you it's a liquid? Who knows?
I know.
Anyone other than Potato? Susie, go ahead, Susie.
I guess that because the perfume takes the shape of its container.
Exactly. Everyone say that. Perfume takes the shape of its container.
Perfume takes inside of its container.
Very good. Is there something that's perfume shaped? No, it's just the shape of its container. What about spraying perfume? Go ahead, spraying perfume. Very nice. Excellent job, everybody. It's a gas. We know that. Why? Why do you think that? Why do you think it's a gas? Potato?
It floats.
It can float.
Spraying. It floats.
Excellent. What's another reason? You know it's a gas because it can float. Why else? Thomas, did you have another reason? It could float. Why else do you know it's a gas?
Because it has no shape and size.
Excellent. Very good. It has no shape. Oh. All right, go ahead and do this one. Very nice. The glass bottle is a solid, and we all know that because the bottle can keep its own shape. What about a bottle of ketchup? Go ahead. Is the ketchup inside a solid, a liquid, or a gas? All right, we have a mix of solid and liquid. Everyone, unmute and tell me, is there something such as ketchup shaped? Do you know what ketchup shaped is?
No.
Solid.
No.
Yes.
Solid.
Oh, is there such thing as ketchup shaped? Can I have a ketchup shaped phone? So let's try again. Go ahead and draw your lines. Good. So the reason this is different is called thickness. Ketchup is a liquid, but it is thicker than water. For example, magma is a liquid. It is just thicker than water. Milk is a liquid. Slime, all of these, they're just thicker. If it's thinner or thicker, this is called a new word, viscosity. You don't need to know this word, but some liquids are thicker or more viscous and other liquids are thinner. But if I pour ketchup into a tall, skinny glass, what happens to the ketchup? How about John? John, if I pour ketchup into a small, skinny glass, what happens to the ketchup? What shape will the ketchup be if I pour into a tall, skinny glass?
It will be a tall, skinny glass.
Exactly. It changes shape to fit the glass. Let's try another one. All right, go ahead and draw. Very good. There's no such thing as slime shaped. It takes the shape of its container. It just changes. Slime changes shape slower than water because it is thicker. It is still a liquid. It still changes shape to its container, just slower.
Question.
And actually, everyone go ahead and read that. Slime changes. Ready? 1, 2, 3. Very good. Question, go ahead. What's your question?
Is the slime like a oobleck?
Yeah, similar to oobleck, exactly, but slime is always a liquid, where oobleck is sometimes a liquid and sometimes it's a solid. All right.
Miss Miranda.
Next one.
Miss Miranda.
Yes, go ahead.
If there is the word is black, we draw a line to both solid and liquid.
Yes, so if I didn't put oobleck on here, but if I did, you would draw a line to solid and liquid. All right, very nice work on this one, guys. Maple tree is definitely a solid. It keeps its own shape. Water vapor, go ahead. Very nice. Once it gets too hot and becomes a vapor, it's a gas. It has no shape. Solid, liquid, or gas? Thick and gooey. We haven't talked about properties of liquids too much, but remember, some liquids are thicker than others. Everyone, please read this about the mustard. 1, 2, 3.
This mustard is thick and gooey.
Very good. So thick and gooey, we can't really use gooey to talk about solids. Thick and gooey is that sticky and slimy, and you want to squish it like this. That's going to be a property for liquids. What about a gas? What property is there of a gas of this animal? Raise your hand. What property of gas might this animal have? Thomas?
Stinky.
Yeah, exactly. This skunk is very smelly or stinky. This is a word that we can use to talk about gases. And what about this slinky? What property do you see here? Anyone have a guess about what property this solid might have? Okay, Pony. All right, let's take a look. This toy is bendable or bendy or flexible, right? Can we use flexibility to talk about a liquid? Everyone answer, everyone. Can we use flexibility to talk about a liquid?
No.
No. But we can use it to talk about a solid like this slinky. Today we learned, everybody read this. 1, 2, 3. Today. Very good. Okay. Any questions?
Class Dojo, I'm just going to write it quickly here since we don't have too much time. Star students. Star students, a lot of you guys did very, very good today. Some of you were a bit quiet. I'm going to turn that off. Okay. Star students today, this is very difficult. Let's have, I think our star students today were, let me open the video so I can look at all of you. Let's do, I'm going to pick a few. Potato, Jack, Thomas, Robert. And that's all for today. You guys did a very good job. Nick, you need to raise your hand more. Toy Ang, you need to raise your hand more. Susie, Pony, you guys too, my girls. Let's get those hands up, okay?
All right, but actually, you guys did a very good job today. I'm very happy. Potato, Jack, Thomas, Robert, I will give you your point on Class Dojo after class. Homework is just a worksheet. Is it a solid, a liquid, or a gas? When you are finished, please take a picture and send it. This is what the worksheet looks like, and you need to circle solid, liquid, or gas. That's all. Okay, everybody. I will see you all tomorrow. Have a wonderful